That's the modulus of Z1, Z2, which is our left-hand side. So now let us check for right-hand side. Modulus of Z1 times the modulus of Z2. For Z1 equal to 2 plus 3i. What is the modulus of Z1? The modulus of Z1 is root 2 squared plus 3 squared. The answer here is 4 plus 9. So now the modulus of Z1 is root 13. Okay, then for Z2, which is 1 plus I, the modulus of Z2 is root 1 squared plus coefficient of I, which is 1. Then the modulus of Z2 is root 2. So now, what is modulus of Z1 times modulus of Z2? What is modulus of Z1 times modulus of Z2? The answer is, the modulus of Z1 is root 13 times root 2. You know that from when you have root A times root B, the answer is root AB. So therefore, root 13 times root 2, the answer is root 13 into bracket 2, which is root 26. So therefore, left-hand side equal to right-hand side. Therefore, proved that modulus of Z1 times Z2 equal to modulus of Z1 times modulus of Z2. So that's the answer. Number 1. Property number 2, when you have modulus of Z1 divided by Z2, when you have modulus of Z1 divided by Z2, this is the same as modulus of Z1 divided by modulus of Z2. When you have modulus of Z1 divided by Z2, is the same as modulus of Z1 divided by modulus of Z2. Property number 3, when you have modulus of Z power n, this is the same as the modulus of Z, then finally power a, power n. You first find the modulus, then you put the power. So let me try to give an example here on number 3 to prove that. Example, prove that the modulus of Z power n is the same as the modulus of Z, then power n. For Z equal to 1 plus I. So let us use n as 2. Let us use n as 2. So we're going to prove that the modulus of Z squared is the same as the modulus of Z, then finally square that modulus, when Z is what? 1 plus I. So now, let us do this example to prove that the modulus of Z squared is equal to the modulus of Z then squared. So we have example here as Z equal to 1 plus I. So let us use the left-hand side. Left-hand side is equal to the right hand side. Our left hand side, we have modulus of z squared. So meaning that we're going to find z squared. So what is z squared? Z squared equal to 1 plus I, then squared. So which is 1 plus I into bracket 1 plus I. We just expand. This is 1 times 1, which is 1. 1 times I, which is I. I times 1, which is I. I times I, which is I squared. So this is 1 plus 2I. I squared is negative 1. 1. The answer is 2I, meaning that z squared equal to 2I. So what is the modulus of z squared? Is the modulus of 2I. So what would be the modulus of 2I? Yeah, it is square root of 0 squared because real part is 0 plus 2I squared. I mean plus 2 squared because coefficient of I is what? 2. So this is root 4. So square root of 4 is what? 2. So the modulus of z squared is 2. So this is our left hand side. So we're going to do right hand side. Right hand side, it is saying it is the modulus of z, then squared. So what is our z? The modulus of z, because our z is 1 plus I, we're going to find the modulus of 1 plus I, which is root 1 squared plus coefficient of I here is what? 1. 1 squared again. So here the modulus of z is root 1 squared is 1. That is root 2. Then what is the modulus of z? Then squared. That is root 2 into bracket square, squared. This squared removes what? Square root. The answer is what? The answer is 2. You see now, right hand side equal to left hand side. So we say that since our left hand side equal to right hand side, then the modulus of z squared is the same as modulus of z, then squared. So it proved that the modulus of z power n is the same as the modulus of z, then power n. So that's what I wanted to show you. I think you don't have any problem here. So let us try to meet next time. May God bless you.